where you will be learning about how OTTs they recommend they recommend your search result. They recommend you videos based on your past uh, data. So, Andrew, over to you and have a great session, everyone.
All right. Well, thank you, sir. Really appreciate that. Hi, everybody. How are y'all doing today? Hopefully, we're all doing good. Good evening, good morning, wherever you are located. I'm here in Texas, so it's good evening for me. But it's a pleasure to get to talk to y'all today. Really, really excited to get to walk through y'all through this little workshop. Kind of show you how we how data scientists work in practice, right? Get to show you some cool Python codes and show you some cool EDA. Maybe even throw a little bit of like LLMs in there towards the end. It'll be a really, really good time. Okay, so I'm really excited to get to talk to y'all. I'll go ahead and share my screen on my end, and after I have just a few slides, kind of want to walk y'all through, and then afterwards we'll jump to a notebook to kind of get through stuff. I believe operations. We sent the notebooks out, all the materials out to the people in the webinar. But if not, let me know. I can put the GitHub link in the chat, and I can do that. So, because if y'all want to walk along with me, I definitely can. That's going to be a big thing for us today. So let me go ahead. I'm going to share my screen. And all righty. So hopefully we should all be seeing my screen here. I'm also going to, this should be okay. Oh, there you go. Okay. All righty, guys. Just a few slides to kind of walk us through, and then afterwards we will jump into the coding demo. Okay. So go ahead and just start the slideshow, and we can get going. Okay. So like we already talked about today, we're going to be talking about how data scientists work in practice, right? And my name is Andrew Castillo. Just a quick introduction to me, kind of was already covered, but I'm a data scientist at Covermymeds. Covermymeds, if we're not too familiar with that. Oh yeah, for sure, but yeah, definitely. How about this? Let me go ahead. Actually, if operations, I think they're asking for the notebook. If y'all can please post that in the webinar chat, that would be awesome, and that way we can get that going. If not, I can do it right now. Thank y'all, appreciate it. But if it's not posted, I will do it for you. Okay. But like I said, my name is Andrew Castillo. I'm a data scientist at Covermymeds. Covermymeds, if you're not familiar with it, we are part of a larger kind of healthcare company called McKesson. Okay, McKesson is a huge global healthcare company. They work in a variety of different things from medical distribution, and Covermymeds is part of actually is their pharmaceutical arm. So a lot of what I'm dealing with is going to be more on the prior authorization space for medications. So pretty much trying to understand why prior authorizations, or as we call them in the industry, PAs, why prior authorizations are approved, why they're denied, trying to understand what, if PAs are going to be needed or not, what factors influence prior authorizations, things like that. And a lot of my work has really been focused around the NLP side of those things, right? So again, understanding which questions on the PA, right, influence the outcome of the prior authorization. Understanding why prior authorizations get denied from messages that we get from insurance plans, things like that. So a lot of my work has been kind of focused on the NLP side. And I've also done a bunch of other things like anomaly detection and doing a bunch of unsupervised learning, things like that. Okay, so those are really cool things. I'll be more than happy to talk to you about more of my background if y'all would like. Before I became a data scientist at Covermymeds, I was actually a PhD in math at Ohio State, and it was there where I was actually a teacher for like 5 years or so. So I'm really, really, really excited. I love teaching. I love getting to talk to y'all, and especially in this setting, it's always a pleasure to get to speak to y'all. Okay, so just a little bit about me. And then if we can go to the next one. Okay, so today we're going to be talking about movie analytics, right? So Amazon movie and TV show analytics, right? And when we think about these TV show analytics, right, what we want to try and understand is like, why are they interesting, right? When we have certain TV shows, right, or certain movies on these platforms, right, what can we do with those types of analytics? What can we do with that kind of data, right? So first off, right, these analytics or this data allows us to make data-driven decisions, right? And it can be these decisions about emerging products, maybe existing products, maybe we want to make a new TV show, maybe we want to kind of sunshine or to kind of deprecate a TV show, right? Maybe we want to make like a new movie, right? Things like that. Maybe we want to try and figure out how to bring more people to the platforms by bringing in certain types of TV shows, right? Things like that. And these companies, right? Think about these big companies like Amazon and Netflix and like Disney, because Disney has like Hulu now and ESPN Plus and all those things, right? They're sitting on massive pools of data, right? And the idea what they're trying to do is understand patterns, right? And the data scientists there are trying to essentially understand what those viewers are doing, okay, and what they're doing and why they care about them. Or what are the viewers currently watching? Why are they watching it? And can we do something about it, right? Can we make new shows? Maybe bring in create new shows or bring in new shows for our viewers to watch and for our viewers to stay on the platform, right? Because that's ideally the big thing with these companies is you want to have them continuously watching Netflix movies, watching Amazon movies, watching Disney movies, things like that. Okay, so a lot of these types of analytics that we're going to be showing y'all today, that's kind of what we care about, right? And Netflix has done something very similar to this. Back in like 2011 or 2012, they actually used their kind of analytics to show, right, how you can they pretty much looked at their data and their analytics to create new shows such as House of Cards, right? So Netflix actually identified, right, that the British version of House of Cards was actually really well watched, right, by a lot of subscribers, right? Everyone really liked it. And they found there was correlations, right, between the fact that people liked the British House of Cards show, but then they also favored movies who were watching Kevin Spacey, or who starred Kevin Spacey, excuse me. So Netflix kind of realized there's these correlations here, right? So what if we make kind of a American version of like House of Cards, but what if we can actually get Kevin Spacey to actually star in that TV show, right? And if y'all remember that TV show, it actually did very good for a really long time. So it was actually a really good bet by Netflix. And actually what kind of enabled Kevin Spacey to kind of go into that platform and kind of get started there, which is pretty cool. So again, there's one example of that, but there are other kinds of examples that exist out there. But Netflix has kind of done this in the past, but I think it's pretty neat. Okay, so something to consider there. So what's kind of the agenda for today, right? So we have a data set, this Amazon movie TV show data set. We're going to kind of explore the data from the point of view of a data scientist, kind of looking at it for the first time. Okay, so pretty much you're going to see my thought process, kind of just looking at it. And what we want to do is just kind of explore the relevant features, right? Understand, kind of go into the analytics, and foresee if we can find anything interesting from it, right? We want to understand the basic Python fundamentals, right, of how to actually perform, kind of elementary exploratory data analysis, right? So look at features, look at correlations, be able to understand various patterns, do things like feature engineering, be able to understand how to create new features and understand things from those existing features. So we're going to understand things like the genres of the movies, durations of the movies, and as well as the TV shows, their ratings and all of their intercorrelations, okay? And then at the very end, we're actually going to use just some basic LLM techniques that we have here to dive into the text data and be able to pretty much kind of understand like what kind of topics, right? What kind of movies do we have in this data set, right? Because this data set has like maybe like 10,000 different movies and TV shows. But can you imagine if we had millions of TV shows, right? I want to show y'all some methods that we can look at the descriptions and be able to understand what kind of movies are actually in this data, what kind of TV shows are actually in this data. Right, and we can actually do that via this kind of LLM topic modeling, as well as we are going to make just kind of a personalized movie recommendation, right? Kind of a little product from user queries. So if you want to watch a movie about sports, I'll actually be able to kind of show you how once you give me that query, I can kind of list you the top 5 most similar movies about sports to your query. That way, if you type into whatever query you want, I'm going to show you the top 5 relevant movies about sports or about, I don't know, historical documentaries, whatever it might be. Okay. So fun little topics for today that we're going to be looking at. All right. So just some expectations for today, y'all, right? So first off, please ask me any and all questions that you have. Okay. I'm here to kind of walk y'all through this. I'm here to chat with y'all and kind of show y'all how we think. Okay. Again, feel free to ask any questions that you have in the Q&A. If you want to put your questions in the Q&A, that would be awesome. We actually have a TA with us here to help me answer your questions. Okay, so if I don't get to it, he will get to it. But I will be monitoring the Q&A for us just to make sure that I can chat with you. Okay, so definitely always feel free to interrupt me, or I'm always happy to talk about it. I want to make this as the best experience that I can for you. Right. So if you need to ask a question in the Q&A, feel free to do that. We're more than welcome to answer anything. Okay. And I'm going to try and go at a nice pace. I know we're all kind of at different backgrounds. Okay. So I definitely want to try and kind of go at a steady pace for everyone so we're all able to follow. Okay. So if I'm going too fast or too slow, please let me know and I will be doing that for you. Okay. So something to keep in mind there. All right. And then let's see, with that said, okay, could you go ahead and in the webinar chat, that way we can have that there for us. Can you please put your name, kind of your current role, that would be really great, or maybe even your desired role, right? Your location, as well as your company, or maybe even your desired company in which you would be willing to look at, okay? So this will kind of give me an idea of your background and we can chat, okay? Which part you don't have the link? Okay. So how about this? Can y'all go ahead and put your name, your designation, location, and company? Feel free to put that into the webinar chat for me. And then I will go ahead and get the link for us and I'll put that in the webinar chat for all of us. But this will also give me an idea of your backgrounds while that happens, okay? So let me go ahead and while that's going, I got a public GitHub repo. Oh. Okay. And then, oh, I'm sorry, guys. In the Q&A, I think the webinar chat might be disabled for everyone, so it might be good to put it in the Q&A, I think. And then in the webinar chat, I am actually going to put the link to the GitHub that's going to have the demo session notebook that we're going to be walking through. It's going to have the CSV in which you're going to read stuff from. And it's also going to have the PowerPoint from today. So you're going to see here how we have the notebook. We're going to have the CSV, and then we're also going to have the PowerPoint. Okay. These are from Georgia. Awesome. Inventory control. Awesome. Got somebody in Dallas working in cloud engineering and analytics. That's awesome. Always good to meet a fellow Texan. Looking for data engineer roles in Massachusetts. That's awesome. Aziz, product, e-commerce. Nice. That's awesome. Very cool. Ajit. Google, software engineering manager. Fantastic. That's awesome. Another Dallas. Very awesome. Very cool. And that SharePoint. Awesome. That's great. Taking classes in ML and use Python. Fantastic. Awesome, guys. Very cool. ML ops at biotech. Oh man, yeah. ML ops is so important in the ML lifecycle. We definitely need more machine learning operations engineers. So valuable. From Chicago, cool. Data engineering, fantastic. Abhishek, San Francisco, startup founder. Fantastic. In the Bay Area, startup founder, that is awesome. Very cool, guys. Very cool. Senior engineering manager at Target. Nice. Awesome. Dallas. All the Dallas people. That's awesome. Data scientist at Cyber. Awesome, Alice. Good to see you. Fantastic. Very cool. Very cool. All righty, guys. Excellent. I really appreciate y'all doing that. That's awesome. Okay. So like I said, there's going to be the demo session here for us to walk through. Again, we're going to spend a lot of time going through basic EDA on the data set. Okay. Because again, we're all kind of coming from different backgrounds. At the very end, I kind of show you how we can build a very basic recommendation system from user queries. Okay. So because we have the user queries because we don't necessarily have like user analytics data, at least just yet. So we would do it from user queries. I saw there were some questions in there. Awesome. Very cool, guys. Very cool. Excellent, guys. Excellent. I really appreciate that. Thank y'all so much. Okay, cool. So hopefully we can all see this CSV here. That'd be actually CSV. See this GitHub here. If you want to go ahead, you can clone it if you want. You can also just download it. If that's going to be easier for you, whatever works for you is kind of up for y'all. Okay. So we're going to be seeing a variety of different things in this workshop. So I'll kind of go back to the slides real quick. So again, just a variety of different things that we're going to be looking at. So for example, with the basic EDA, what we're going to be seeing is understanding kind of like the average duration times of movies based off of their genre, right? So that's going to be pretty neat to do because, right, these genres or these listings that are kind of given in the data set are kind of given as multiple different items, right? So we want to be able to split things up right? To be able to understand, okay, well, just for dramas, just for actions, just for fantasies, how long are those movie times, right? And let's see if we can actually validate anything that we kind of know, okay? So I'm gonna show y'all how we can at least do this in practice. And for movies, we're also gonna do a very similar thing for TV shows. But now for TV shows, we have to be cognizant, right, of how long the average, because the TV shows, right, are not necessarily measured in minutes, right? They can be measured in seasons. So by genre now on those TV shows, you want to understand how long are those TV shows based off of those genres, right? So that's going to be something that we also want to explore as well and be able to understand. Okay, I'm going to show you how we can do that in this particular situation. And at the very end, one cool aspect of this is that in the data set, we're actually going to be looking at, again, a bunch of descriptions, right? So those descriptions of those movies and TV shows are going to have text data. So what we want to try and do is be able to essentially understand what kind of topics are going to be available inside of the movies, right? So for various topics, we can see, oh, look, we have maybe some crime topics appearing in this guy right here. We have maybe like a paranormal or a haunted kind of scary movies kind of appearing in this guy. Maybe some comedies, which are pretty interesting in this topic. Maybe we see a bunch of various comedies, maybe some dramas that are occurring in these two topics right here. So we have a variety of different topics that are going to be occurring in the descriptions. And I'm going to kind of show you how we can do that, at least a quick and dirty way, via some basic topic modeling that we can kind of build out from scratch. Okay. So a variety of different things that we're going to be looking at, and I'm pretty excited to kind of show y'all and see what we can do there. Okay. So with that said, if there aren't any questions, and feel free to put any questions in the Q&A. If there are any questions, we can go over and hop onto the notebook that we're going to be looking at. Okay. So the notebook itself, y'all, I tried to really go ahead and document it fairly well for y'all. That way you can kind of run it smoothly. What I recommend doing when you want to run this is you might need to go ahead, depending on your local setup, you want to try and maybe do it in Google Colab, just so it's really easy to get up and running as efficiently as possible. It might help to also be on a GPU if you have one available, especially when you get towards the end. We will need to go ahead and be able to use sentence transformers, what it's called, to be able to embed these descriptions. Being able to do that, as well as being able to topic model these things, is going to be much faster on a GPU. So just something to consider there. But if not, that's totally okay. For like 90% of the notebook, you'll be okay if you don't have a GPU. You can be on a basic CPU. So what we're going to do is we're going to go ahead and import a bunch of basic Python libraries. So for those who are familiar with these, that's awesome. But maybe for those of you who are not, we're going to have just a few basic libraries that we need to import. So for example, things like pandas and numpy, right? Pandas is going to be kind of our data manipulation kind of tool of choice. We're going to, data scientists use this a lot for basic importing data frames, being able to manipulate them, doing feature engineering with them, creation, processing, cleaning, all that good stuff. We want to use pandas as our primary tool in order to do that. Okay. And we also want to use NumPy to be able to manipulate some type of arrays that we're going to be actually considering as well. We're also going to be using Matplotlib and Seaborn, okay, to also be able to visualize the various graphs that we're going to be looking at. So that's going to be really interesting as well. Then we're also going to be using some things from like scikit-learn to be able to process the data. And I'm going to show you how we can do that in Colab, where you can actually use this this Google AI client to help you kind of code from scratch, which is pretty neat. It's kind of cool that a lot of companies are starting to do that. And also just some other things to help us clean some data with like the regex module. And we're going to just be kind of choosing just a kind of style that we care about. Okay. But then we're also going to be importing, I kind of already did this because it does take some time to import. But we're going to be importing some beefy libraries that we're going to need. So things like sentence transformers, UMAP, HTTP scan, as well as BERT topic. But again, we're not going to need this until the very end. So if you need to skip this because you might be running into like memory issues, totally okay. That's totally fine. Go ahead and skip this for now. If you want to come to the very end, you can at least watch me do it. Because again, these do require a little bit more beefiness to be able to process them. Okay. So something to keep in mind there. And then once you've actually installed them, you can go ahead and you can import them as such. So we're going to import UMAP, HTTP scan, sentence transformers. We're going to be making a bag of words vector as well as some stuff for topic modeling. Okay. So kind of just setting the table here, y'all. But are there any questions so far? questions and kind of what we're doing there before we kind of dive into the EDA? Very cool, very cool. Okay, so now what we want to do is we want to go ahead and we want to actually import the data that we have. Okay, so various ways to do that. So what I did, just to kind of make it easy, is I have kind of a sample data folder in my Google Colab, and I pretty much just put the Amazon Prime titles that are there, and I kind of just drag and drop it. And then once that's there in my Colab notebook, I can go ahead and peel it in by just going into that directory, peeling in that CSV. I am going to go ahead and yeah, towards the very end is easy. Yeah, definitely. So we're going to kind of show you how to do that based off of user queries. Yeah, right, exactly. So we are going to pull this in on the sample data and then visualize it with the first top 5 rows of the data set. Okay, and I kind of already did this just to kind of make sure things are working. And there is a pandas method. So PD means pandas. So it's going to be pandas.readCSV, and we are going to be reading it in from this directory. Okay, so this is going to be a CSV that we're pulling in, and we are going to visualize the top 5 rows. Okay, so nothing fancy here, but what we can see here is the data set itself has a variety of different features. So we're going to have movies, our TV shows for the type. We are going to have the title of the movie, some director, the cast that was there, country, all this good stuff, duration and rating, the genres that it was actually listed in, as well as the description. Okay, so we're going to be touching a variety of these different features, and I'll kind of show you how we can kind of look at this from the ground up. Okay, so again, a lot of our time today is going to be spent exploring the data, and at the very end, we'll kind of do some more fancy stuff, I guess you can say. But again, we want to try and make sure that we kind of all are on the same page with how we can explore this data and kind of go from there. Okay, so when we look at this, right, so the first thing we want to do, I kind of want to walk through this cell by cell with y'all, just so we can kind of show you how how we would visualize it. Okay, so we have the data here. One of the first things I like to do is first look at the dimensions of the data, right? So we see here that there are going to be 9,668 records in the data set, and we're going to have 12 features inside of that data set. Okay, so this df.shape method from pandas, it allows us to do that. Okay, and then what we can also do is we can also do a df.info, and what this also allows us to do is it allows us to also see the data types of the data frame, right? But then it also allows us to essentially look at the individual features and understand how many of them are null, how many of them are not null. Okay, so we see here how there's, like we said above, right? There's 9,000 or almost 10,000 records. Like for example, the director feature, about 7,500 of them are actually, not null, right? We have the cast, 8,500 of them are not null. For country, a lot of them, right, are actually null. So some of them are going to be 672 of them are not null. They added, same thing, right? So we see here how we can kind of understand that we can kind of get an idea for how many of the individual records inside of the data set, right, are null or empty. Okay. So what we can do is we're going to go ahead and impute them. So what we're going to do first is actually going to get a percentage wise to see how empty are each one of those features. Okay. So I don't want to go through the code step by step for y'all guys, because I know that can kind of be, it can take a really long time and be pretty tedious. But if there's any questions on the code, feel free to put that in the Q&A, and I'll make sure to answer it, or the TA will in that case. All right. So what we're going to do here is pretty much look at sum of all the null values, right, and then be able to divide it, multiply by 100, and we're going to get a percentage of missing values inside of that column. Okay. So we can see, for example, in the country column, about 90% of them are null, right? So they're empty, which is kind of annoying, right? They added, again, a lot of them are null. Your director, cast, and then also rating, those also have null values as well, but the rest of them are not, okay? So what traditionally we want to do is with these empty values, these null values, we want to go ahead and try and impute them, or we want to fill them in some way. Now, different ways of doing it, again, it kind of depends on the context in which you're going to be doing it. But when I looked at this, I kind of said, you know what? Well, not knowing the director, not knowing the cast, maybe not knowing the date added or rating, it's like there's not really an easy way to get that. So what we can just do for now is pretty much just kind of leave them to be unknown, right? So let's go ahead and wherever the director cast date added or rating, wherever they're null, let's just go ahead and let's leave them to be unknown wherever they're empty. Okay. Now, the cool thing about this, right? So it's actually, if you're familiar with Python, doing this isn't too tricky, right? But if you want to, the cool thing about Google Colab is that you can now actually do pretty much like code completion, which is pretty neat, right? So what you can do, so for those who are not familiar with this, I figured this would be a really simple example to kind of show y'all, is in Google Colab's AI assistant, what you can do is you can actually put in the query that you want to use. And in theory, right, Google Colab will be able to spit out the code for you to use inside of your notebook, right? So if you want to generate this, and it should actually be free it should actually be available with the free version, okay? But you see here how it's kind of giving you some code that you can use here to go ahead and fill in the null values of these particular features, okay? Now, again, this isn't the only way to do it, but it is a way to do it if you choose, okay? So in this case, what we're going to do is we're going to let director, cast, date, added, and rating essentially be the same thing. And then we're going to use the dot fill NA method with unknown, okay? So that's pretty neat, right? We can actually use this Colab notebook, or excuse me, the Google AI to go ahead and kind of allow us to write down code, which is pretty neat if you need to do something that maybe can be a little bit time consuming. Okay, so something to keep in mind there. So we're going to fill in those columns with nulls to be unknown, right? But then we also have this country column. So just to kind of show you something a little bit different and maybe something that's a little bit more complex, what you can also do is be able to fill in the country column, right? With, let's say the country column, because we know for movies, TV shows, we know a lot of them are predominantly going to be made in the United States. So what if we go ahead and we say, okay, let's go ahead and fill in, right? Because if you look at this country column, the majority of them are going to be the United States. What if we just fill in the null values with the most value that occurs in the country column, which in this case happens to be the United States. Now, again, if you want to fill it with unknown, definitely could. I kind of just want to show you something different using a different type of imputer method in case you're curious as how we could do this in practice as well, especially like in a productionized setting. And again, we can do this via Google AI's Colab, okay? So what you can do is you can impute the missing values. We want to do this using scikit-learn's simple imputer. So if you do this, we're going to go ahead and we're going to see that the simple imputer is going to give us code to go ahead and fill in the country column with these values, okay? So now, if we run this, let's see if it still happens. You notice here we actually get an error. So first off, always gotta be careful. You never want to trust this code that it gives you. It's kind of why it says use the code with caution. Okay. Reason for that being is because of the way this array is set up. So this imputer is pretty much going to fit transform all this country column. We're going to reshape it, but if you want to look at it, it's kind of we have a dimension. So if we look at the shape here, if you're curious, we got this dimension, that one dimension, right? This kind of thing as like a column. And then what we want to do is we want to go ahead and take out that column. We want to kind of squeeze it out. So different ways to do this. One way to do it is going to be via a reshape method. So when we do that, we actually now get a single array, which is fantastic. And then now if you want to, you can feed in DF country into it. And then ta-da, now it's going to work. Okay, so you do got to be a little bit careful with the coding notebooks and how this Google AI, all these AI things work. Sometimes depending on the Python version you're using, the scikit-learn version you're using, which I think might be the issue here, it might mess up the code and how you actually feed it in. So just something to keep in mind as you go forward and you do use these tools. We do want to make sure you do use them. I use them from time to time in my day-to-day work, not all the time, but they are kind of easy to do that. Okay. Yeah, for sure, buddy. So simple imputer is pretty much just kind of an easy way for us to impute or fill in missing values. Now it has different methods to do this with, right? So what it's going to do is it's going to look at the column in question. So in this case, DF country, and whatever strategy I care about, it's going to fill in, identify, right? how to actually fill in this particular column. So in this case, I use the most frequent, right? So what it's going to do is it's going to go into this particular column. It's going to look at which entry, right, inside of the country feature occurs the most, right? And what it's going to do, so that's going to be like the fit method. It's going to, when it fits, it's going to understand, okay, what element inside of country appears the most, okay? And then after we identify what element appears the most, we are going to transform it by essentially filling in all of the null values inside of the country column, right, with the most frequent entry that occurs inside of this column, okay? And it's going to be kind of the imputer. It kind of allows us to do things like that for like categorical data, right? But if you wanted to, you can do things like averages, like numerical values. You can do medians for numerical values, things like that. So it allows us to fill in missing values in a kind of a similar way as we just did above. But now we're able to use these, what are called these kind of transforms to enable us to do this, which as data scientists, we do care about, especially when we're starting to productionize our code, right? And we start doing it like on unseen data, for example. That can be things you have to worry about. So that's how we're doing there. It's just a way for us to fill in missing values, and it's a different way compared to what we did above right here. So that's a great question. All right. And again, if you wanted to, you can take this, take out this scikit-learn with simple imputer and do something a little bit easier. That's totally okay too. Nothing's going to harm you from doing that either. Again, I'm just trying to show y'all some different methods here. That's all I'm trying to do. Okay. All right. So now, ideally, once we filled in these missing values, I can run the same code above, and we should now see that all of our values, all of our columns now have no missing values, which is fantastic. Okay. So it's exactly what we're looking for. And now we can go ahead, and there's this sample method on the pandas data frame, which we can call, and we can just look at a sample, right? So a random sample of a bunch of different movies or TV shows inside of this data set. Just so we can kind of spot check it, make sure it looks good, make sure there's something crazy happening there, okay? Just some things to consider, okay? But again, this all looks good to me. We have our movies, we got our TV shows, directors, cast, country, all this good stuff. And now what we can do is we can kind of go in and we can start exploring, okay? So when I looked at this, right, what I kind of first wanted to understand, right, when you look at this type feature that's inside of the data set, right, we have two different, or potentially at least two different ways of looking at the data. We got the data set kind of blocked up in movies as well as TV shows, right? Now, when we look at those, what do the distributions of these movies or TV shows look like? Or are there other ones that we need to consider as well? All right. So a simple way of doing that is just going to be to essentially call that type column, right, or type feature inside the data set by df.type. All right. Do what's called a value count to pretty much count the number of unique entries that are going to be inside of this column. So in this case, movie and TV shows. See how many times movie and TV shows occur. Okay. We're going to go ahead and put it to a pandas data frame, and we're going to do some renaming. And then with that, we're going to actually call what the Seaborn library. Seaborn is going to be SNS, right? So Seaborn is going to be SNS. We're going to call the bar plot method from Seaborn. Okay, Seaborn, remember, is a kind of a library to help us visualize our data. On the x-axis, I'm going to plot the different types of, I guess, mediums that are going to come in. So either movies, TV shows, or potentially others, as well as the number, right, that we can actually get. Okay. Now, if you're familiar with Python, you can also do this via count plot. Totally cool. Again, just want to kind of show you all different methods. Okay. So if you look at this, you now see, oh, okay, so in this data set, there's predominantly a ton of movies, right, which are going to be the 7,814 movies, and there's about 1,854 TV shows, okay? And there's no other kinds of subsets of those, right? So it's literally just movies and TV shows, okay? So potentially going forward, we might want to go ahead and start looking at maybe breaking these up apart from each other, and exploring them separately, right? Because how movies and TV shows act might be a little bit different, right? kind of like, I guess I've heard before that movies in Hollywood are a little bit different from movies in or TV shows in Hollywood, right? So maybe potentially you might want to separate them, okay? And I kind of show y'all how we can do that. All right, so that's pretty interesting. So now in theory, what we also want to do, right, potentially is look at the directors, right? What kind of directors actually occur, right? And which ones occur most often? Again, let's try and understand the data here more, okay? We're trying to do some basic EDA, okay? So I kind of gave y'all the opportunity to go ahead and code here. So if you have an idea how to code this up, you have some experience with Python, feel free to do it right here. But if not, I will go ahead and I'll kind of code it up with you live. That way we can kind of see what's going on, okay? So how can we do this, right? I want the top 15 directors by count. And again, I'm kind of telling you, let's use value counts just to kind of help us understand that a little bit better. So again, different ways of doing this, but in pandas, what you can do is my, so the cool thing is with this Google Colab Pro, it kind of completes it for you. So that's also really plus, but I kind of make sure I do it from scratch for you, okay? So in pandas, what you want to do is you want to call the director column, okay? So the way we can do that is you can call it as stub. So I'm gonna go ahead and call director like that. And again, what Python and Google Colab will do is actually kind of gives you some code completion. So you can actually go ahead and fill in that guy. Now what I want to do is I'm going to call value counts. Value counts is a method for us to actually see by counts the number of entries that occur inside of this director column for each individual entry that occurs. Okay, so for example, if I run this, I'm going to see that unknown occurs inside this column 2,083 times. Mark Knight occurs in this column 113 times. Candace Holder 61, and then so on and so forth. Okay, but as you can see, there's a bunch of them that only occur once. So let's just kind of get an idea of what's happening here. And let's look at the top 15. Again, just to get an idea. All right. So when we look at this, right, we're actually seeing what? Well, we're seeing that unknown actually occurs a lot, right? It occurs a lot, probably a little bit too much. It's kind of, we want to understand, like, okay, is there something that maybe we messed up? Why is that necessarily happening? Because remember, we did fill that in, right, in the unknown portion. What does that actually mean? Okay, a lot of them have Mark Knight, again, some Candace Holder, things like that, but a lot of them really were kind of null to begin with. So why is that the case? Well, one thing we can do, right, is let's go ahead and let's kind of filter down to these unknown records that are inside of our data set. And let's figure out, right, are they movies or are they TV shows? Okay, so that's going to be what this next block is here, right? So let's go ahead, let's filter down to all of the entries inside of our data set that come from an unknown director, okay? And let's figure out how many of them belong to movies and how many of them belong to TV shows. So again, if you know Python, definitely feel free to give it a go. The way I would do this, again, different ways of doing it is you look at DF. I want to filter down to all the records that give me unknown. The way you can do that is pretty much by calling DF bracket. If you want to use a .loc, you can also do that too. Okay. Yeah, that is true, man. Yeah, that is true. This is exactly. So that can also be an option as well. So there could be some data integrity thing and then we have to worry about. Exactly. Yeah, for sure. And if that's the case, there might be like a data engineering thing we got to figure out. There might need to be like a, kind of some SME, talks we have to have, right? Like, why are these entries null to begin with? Because it could be like a missing issue from like an application that kind of brings in the data, for example, right? So you're exactly right. Like if this data is unknown and it really is actually null to begin with, there could be a lot of missing correlations that we could see. So in that case, that would be something that we would do, assuming you kind of worked at one of these bigger companies, 100%. Yeah, I do it in my day-to-day work all the time. Like, why is this thing null? And understanding where data comes from is a really, really big, important job, a part of the job of data scientists. And that's kind of really where we work a lot with like data engineers, software developers, to really understand, right, how this data is being piped in to the data ecosystem at the company that we work at. So yeah, that's a great point for sure. Because it could be null for an unknown reason that maybe they didn't know about. So it might be cool to kind of tell them and then they can kind of fill in those missing things. That happens before all the time for me, especially up in Databricks. Great question, man. Okay, so what we want to do now is we want to go down to all of the unknown records inside of our data set. So where that corresponds to director. So again, it's nice here because Colab Pro gives you this. So I'll go ahead and use it to save us time. But the way you would do it is pretty much go df.director, give me all the directors, give me all the records inside the data set that correspond to unknown. Okay. So everything here now is going to give me all of the records inside the data set that correspond to unknown, right? On the director side. So everything here is going to be a bunch of just unknown directors. Okay. Now, what I want to do is I actually want to figure out what type they belong to. Okay. So again, different ways of doing this. So I'm going to go ahead inside this data frame. I'm going to call the type object, or the type column again. If you wanted to do it this way, you can also do that. However you want to do it, it's completely up to you. Okay. Different ways of doing it. They're the pros and cons, which maybe we can talk about later. Okay. I'm going to call value counts again. And what I'm also going to show y'all is that you can do it's really cool thing in value counts is doing a normalize. So I can go ahead and understand percentage wise, right? For the unknown directors, right? Percentage wise, how many of them belong to TV shows as well as movies. Okay. So we can see, right, that 89%, right, of these unknown directors, right, belong to TV shows. So the majority of these records that have unknown directors belong to TV shows. But now we've got to ask ourselves, do all of the TV shows have unknown directors, right? Because if that's the case, we might need to either go back to the source, understand why that's the case, get that data fixed, right, in practice, or we might just not be able to do much with it, honestly. That also happens before, depending on the data that you have. So in this next cell, that's exactly what we want to do. Let's go ahead and understand. Well, we have the majority of these TV shows having unknown directors, but do all of them essentially have it, right? So again, same exact thing, right? We can go ahead, do df.type, okay? And again, it's nice because this Colab gave us this, which is nice. I'm going to go ahead and call director, and I'm going to normalize it to be true if you want. And look what happens. Well, isn't that a bummer? What does this mean, right? What this means is that we're going to have like all of this, all of the TV shows, right, are going to have unknown directors, which is kind of annoying, right? So it's something we have to kind of keep into consideration, right, when going through this, right? So all the TV shows, it may not be worthwhile exploring the director data set because a lot of them are going to be unknown, at least for TV shows if you wanted to. But again, it might be one of those things where we get to go back to the source and clean that up as well. Okay. So again, just some basic exploratory stuff that we're going to be looking at here, y'all. Okay. But with that said, are there any other questions about the preliminary stuff that we've done so far before we do some more exploratory analysis in the notebook? Oh yeah, that's true. But yeah, so and they should kind of give us correct valid data. That is definitely true. But honestly, man, like for example, like what I've seen before in practice is so for example, there are various like insurance identifiers that we have in my data that I deal with day to day. Sometimes those insurance identifiers are just not null because they are not given to us by the pharmacy. So if that's the case, like honestly, in practice, whenever we're building models with that identifier, we have to actually do some imputation with it to be able to fill it in to do downstream modeling, right? And it's not nothing the data engineers did. It's not nothing the software developers did that made the application to feeding the data. It's honestly just because they're not given to us from the beginning. So that's kind of a thing to keep in mind. Pedro's saying, what do we call we're doing, data science or data engineering? I would call it data science, man. Yeah, I would call it data science. We're just doing a bunch of exploring. We're not moving data. We're not really necessarily moving the data. We're not taking data out of like its raw form, like JSONs or PDFs or something, and moving that downstream for exploratory. All of the exploration stuff that we're doing right now is all I would consider pure elementary kind of data science. Yeah, that's a great question. Data engineering is this whole other monster, which is very important. But that's more for, I would say, a little bit later. But all just purely data science so far. Okay. Any other questions, y'all? Questions, comments from so far on what we're doing? All righty, sounds good, sounds good. Okay, so just to kind of speed up some time, I'll kind of have some code here ready for us to kind of explore the next cells. But we're gonna go ahead and we won't code it all the way up. Oh, great question, but for the unknown, honestly, so in this case, because we don't really necessarily know what the directors are, going forward, I kind of just said, you know what, for the TV shows and directors, I might just go ahead and just kind of not explore that too much. Because again, this is one CSV, right? We can't really do any consulting with like understanding why that's going to be null. But for now, we understand, you know what, it's primarily null. It's how it's given to us. It's all TV shows. Maybe, you know, Amazon has something internally that they make that unknown or null for a particular reason. Maybe they don't associate directors with TV shows, which might look like it's the case, but to my understanding, directors are on TV shows. So for now, we're just gonna kind of leave it alone, but realize and keep in the back of our minds that we can't really do much with the director column with TV shows. So we'll kind of keep that in our back pocket as we explore the rest of the data. Okay, that's a great question. Can data frames? Yep, you're very welcome. Can data frames work with huge data? Well, that's a great question, man. For example, like in pandas data frames, right? They will struggle with data that's on the order of more than, I would say, a few dozens of million, right? If you're working with things that are hundreds of millions of records long, right? Potentially even a billion records long, and depending on the operations that you're doing on them, it can take some time with pandas to be able to process that much data, right? So even with like 10 million records, 12 million records, even a few million records, right? Doing it in pandas may not be the most quickest and efficient thing to do. You might want to do it on a sample of it, just to kind of, you know, get some preliminary exploratory stuff done. But when you're actually working with these huge data frames and you need to do some processing on it, you need to do cleaning on them, you need to do maybe some exploratory stuff with them, that's really where other kinds of languages are really going to come into play. The first that comes to mind is going to be something like Spark, right? So PySpark is a type of distributed language, which some of y'all who are in data engineering, I think we saw some data engineers in the Q&A who kind of told me what they were doing. That's awesome. You know, so maybe data engineers probably use Spark a lot. And Spark is able to process, millions and millions and millions, potentially even billions of records at a time, depending on if you're working with that much data. But again, it kind of just depends on the situation. But usually, for just preliminary exploratory stuff, I think it's easier to kind of get an idea of what's happening in pandas, and then from there, or Python, like pandas, and then be able to explore that and maybe take that over to Spark if we need to. So yeah, that's a great question. Exactly, Aziz. Yep, exactly. So if you're going to do some basic EDA, as long as it's like basic statistics and stuff like that, definitely do that like in SQL. Do a sample of it. It's probably my recommendation. So take like 10%, 20% of the data set and do it there. Because in theory, that sample, if it's representative, should kind of tell you things about the entire population that you do have. So yeah, definitely want to do it on a sample or potentially SQL if you can, or PySpark if you even want to take it that extra mile if your company does have Spark capabilities. So 100%, I agree with that. All righty, y'all. Great questions. Anything else so far? Questions, comments? All righty, sounds great. All right, guys. So like I said, too, when I was looking at this, I said, okay, well, you know what? Is there anything interesting about the ratings, right? Maybe we can kind of look at that. So what I kind of want to show y'all is just be able to kind of graph some basic plots from the ratings, kind of show you this idea of a hue. And we can kind of go from there. We don't really do too much past the ratings, but I kind of want to just show y'all some of the things that we're seeing, because again, this is really good to understand from an exploratory standpoint. So what I'm going to do is pretty much just go ahead and take in my Seaborn library. I'm going to do a count plot. So I'm pretty much going to go into the ratings column, and it's going to count for me the number of times that any element or entry inside of that column go ahead and appears inside of the data set. Okay. And we're going to go ahead and use Seaborn to do that. We're going to make some plots here. And we can see here, right, that like, for example, 13 plus, 16 plus, all these are occurring a good amount of times that are inside there. All ratings is occurring in there, which is interesting. 18 plus, rated R, PG-13, 7 plus, unknown. So you see a bunch of different things. So it's just kind of like thin tail that's kind of occurring out here for all of these kind of, I would say, maybe unique ratings that we would get. So that's pretty interesting. when I was looking at this, I also said, okay, well, what about, is there a distribution between, there's a number of movies here, should we just number? Between, if we look at this, what if we actually kind of break it up by movies and TV shows, right? Because these movies and TV shows do have ratings that are separate. So is there any difference there? Maybe we take a look at that. So we see here, so these 13 plus ratings, it looks like predominantly, mostly movies. A few hundred of them are going to be TV shows. So you see how this hue right here, we can actually separate the movies from the TV shows, right? So this is pretty cool. Seaborn gives you this kind of really quick ability in order to do so. We see maybe here 18 plus, again, predominantly movies, rated R, predominantly movies, which makes sense, right? Like R, PG-13, PG, those are all kind of movie ratings from kind of like my little knowledge that I know from just watching a bunch of movies. But we also see some other things too, for example, right? Like we see like TV PG, TV NR, we see G and TVG. Are those the same thing? It looks like one's for movies and one for TV shows. TVMA is mainly for TV shows, you know, things like that, right? So again, we don't really do too much with this, but just something, a food for thought. Like if you want to take it, if you want to maybe do some more with it, how would you maybe combine these ratings together? Does it even make sense, right, to combine these ratings together, right? Depending on the kind of problem it is that you're trying to solve, right? Like if you're looking at things purely from movies, you don't want TVG to also be kind of influenced in there, and vice versa, right? So just some kind of food for thought to consider, right? Like, you know, there are things that are similar here, some type of ratings that are similar. Does it make sense to combine them? Why would you combine them? When would you combine them downstream? Again, depends on the context, but just some food for thought as we kind of move on, okay? So again, not much else that we're done here. I just kind of want to show y'all this and maybe have y'all think about it and maybe explore it on your own if you would like, okay? So kind of leave some open-ended questions there. So that's kind of what the ratings, what I really found interesting, at least when I was exploring it, was this listed in feature. Okay, is this listed in feature? This is really where y'all, we're gonna start doing a lot more feature engineering here. So if ever I go too fast, please let me know. I will be more than happy to kind of go over some more code for you. Okay. So this listed in feature is very interesting, right? So first off, if we go ahead and we look at the number of unique genres which are these listed in, which are these listed in entries here. If we look at all of these different genres, like how many are there and why, right? So how would we do this in practice? You can go ahead and call this listed in feature, or this listed in, or call a listed in method. Okay, very similar to what we did before. And then we can call the nUnique method from that. So when we look at this, right, we actually see that in this genre or listed in kind of feature, there's 518 unique entries in there, which makes you think, right? Like, huh, okay, that's interesting. I wonder why that's the case. Like when I first thought of this, I'm thinking, okay, well, I guess that maybe is drama separate from drama comedy? Is like comedy drama different from drama comedy, right? Are there a bunch of different genres that are kind of being concatenated with each other to describe a movie, which these movie studios want to do, right? Because they want to try and get the most views that they can on their movies. So, you know, you may not be a fan of drama, but maybe you like comedy. So if we list it as a drama comedy, maybe you'll come watch the movie, right? Things like that. So when I was looking at this, I'm thinking, okay, there's 518 genres. Okay, that's interesting. So what if we just plot the top 15 of them by counts? Okay, so a very similar thing that we've already done. So when we do this, what are we seeing here? So when I'm looking at this, okay, I'm first off seeing, so the blues are movies, the orange is going to be TV shows. The blue, we have a bunch of comedy dramas, but then we have comedy and drama that are separate. We have horror and suspense, which is different from horror. Interesting. Okay. We have drama and romance, which again is separate from drama. Kids is kind of its own little thing. Well, I guess kids and animation occurs. Those occur a lot with TV shows. So we're starting to see, right, how a lot of these different genres occur with each other, right? Which for me, when I was looking at this, I'm thinking, okay, well, if we want to get some statistics, you know, the signal, right, of comedy drama is being kind of drowned out by drama and comedy, right? Like we have the signal being interspersed between different kind of listings that the movie theaters did. So if I want to understand on average just how long movies are that contain the listing drama, how can I do that, right? Because this isn't going to be enough, right? In theory, if I want to understand how long these movies are on average, for movies that contain drama, I have the drama column, but what about comedy drama? Is that not a drama? What about drama romance? Is that not a drama, right? So we want to be able to essentially take these features or these genres and split them, right? We want to split them to essentially allow us to understand, okay, well, how can we understand things about these individual dramas single-handedly, right? And how they relate potentially to each other, but also to other things inside of the data set, okay? So that's what I want to look at now, okay? I want to understand, okay, how can we do some feature engineering to split these genres up? And after we do that, be able to calculate some basic statistics, okay? So one way to do that is going to be as follows. So the first thing I'm going to do, if you look at this arts, entertainment, and culture, I'm going to go ahead and just rename it to be arts, entertainment, and culture without any commas. That makes the cleaning portion for what I want to do, it makes it easier to do. We're going to do this via this regex.sub method. So pretty much just saying wherever this arts, entertainment, and culture with the commas occurs in the data set, go ahead and replace it with everything without the columns, right? If it occurs in there, all right? Otherwise, just give me the original column that was there, okay? So this is pretty much just some basic data clean that we're doing, and you'll see why, all right? So now what I want to do here is I'm actually going to make a new column inside of my data set, okay? And how am I going to do that? I'm going to go ahead and create a new column called genres. And the way I'm going to do that is going to be via that genres are listed in feature. I am going to apply, okay, a lambda function. So a lambda function now is pretty much just a temporary function that we can use in Python. It's a quick and dirty function. It doesn't have to be stored anywhere, right? We can actually just call it single-handedly. And it's quick and it's nice and quick and easy for some basic EDA stuff. Like I don't want to have to write def function name. Here are the inputs, right? Here's what I want it to do, right? Like let's just do some basic things just so I can kind of see what's going on. All right. So it's a quick lambda function. And what I'm going to do is I'm actually going to return a list inside of that column. So what I'm going to first do is I'm going to strip off any white space. And then I'm going to go ahead and split on the names of these genres that are occurring here. So what does that mean? That means whenever there's a comma, I am going to split on that comma. So I'm going to make a new list, right, from that. So for example, horror and suspense will turn into a list, horror, comma, suspense. It's not going to be just one string anymore, okay? So for example, if you want to kind of look at this in action, if I look at horror, comma, suspense, this is going to be a string, right? So if I look at this in Python, Python's going to treat that as a string. But if I do a dot split and I split it on the comma, now it's going to be a list, right, of horror and suspense. But I do notice there's some kind of trailing white space here, which I don't really want. So I'm going to go ahead and strip it, which is what I'm doing here, right, to kind of take that white space and remove it. Okay. Again, this helps with the cleaning. All right. So when I do this, look what happens. I now have a new genres feature that's right here that gives me comedy, drama, and they're both their individual strings. I have drama international, they're both individual strings. Action, drama, suspense, their own individual strings. Right? So I'm able to go ahead and make each entry inside that list its own individual string. Okay, so now I'm able to just separate them, right? I don't want them to be considered the same thing. I want us to separate. Okay, and when I do this, what I essentially want to do is I want to take all of these features and I essentially, this genres feature, and I want to make a new feature to indicate that this movie at some point in its listing column belongs to comedy, or it belongs to drama, or it belongs to international or horror or whatever it might be, okay? So this is what's called one-hot encoding, right? I want to take these genres and I essentially want to take them and make a new feature for each genre, okay? And allow that new feature to indicate to me for that movie or TV show if it's listed inside of comedy, drama, or whatever it might be. So now, when you're doing this, right, you can do this by hand. It's going to be very time consuming. We don't recommend you doing that. But what's nice is that you can actually do this via Scikit-learn's multi-label binarizer, which is fantastic. So essentially what it's going to do is it's going to do exactly what I want it to do. It's going to look at all the genres. It's going to look at all the individual unique strings that occur inside this genres column across all the lists. It's going to give me the unique ones, right? And then we're going to take our new data set and we're going to make a new one, a new column for comedy, a new column for drama, a new column for whatever it might be. I'll show you what this looks like, okay? So in order to do this, I'm going to make a multi-label binarizer object. I am then going to fit transform on this new column that I just made, okay? When I fit transform, I am pretty much going to understand which features or which entries occur inside the genres column, and then I'm going to one-hot encode them, all right? And when I do this, look what happens. Doesn't this look a lot more cleaner, right? These are the actual dramas that we care about inside of our data set. So I have action, I have adventure, I have anime, art house, kids, military and war, right? Just these other kinds of genres that are a little bit more concise and they're separated now, right? And they're not going to be concatenated anymore. So when we do this, look what happens, right? When I do this, look what happens. So now what I'm going to do is I am going to take the data frame of what I just did. So all of this fit transform stuff, I am going to make it into a pandas data frame as so. So whenever you call pandas.data frame, I'm going to make a pandas data frame. I'm going to make it from this array up here. I am going to make the columns, the classes that I'm getting out from here. Okay. The classes that we actually found. So in other words, the genres that we found. Okay. And then I'm going to go ahead and index it. And then when I do this, I'm going to go ahead and take the original data frame that I had. I'm going to keep the title. I'm going to keep the movie or TV show type. I'm going to keep the listed in, the genres column that I just made, as well as all of these one-hot encoded features that I just made. Okay. And I'm going to concatenate them along the column. So when I do this, look what happens. Doesn't that look a lot better, right? So for example, oh, and this display max columns here pretty much just allows us to see all the columns, okay? So for example, The Grand Junction, this is a movie, it's a comedy drama. Again, I don't want it to just be a comedy drama. Is it a comedy? And it's also a drama, right? So I'm gonna go ahead and comedy, it's gonna be a 1 because it's a comedy. It's gonna be a drama because it's a drama. And then everything else is gonna have zeros, okay? Because it's not listed in anything else besides comedy and drama. So for this movie, Take Care, Good Night, Drama International. So in theory, if I did this correctly, I should have my drama occurring as well as international occurring right here. And then everything else inside of this record, of this row, is going to be zeros. Okay? So again, we're able to pretty much kind of take our column and one-hot encode it. So in this case, now what we can do is we now have a relationship between the movies and their genres, as well as which genres are actually listed in individually. Okay, we don't necessarily have comedy drama being separate from comedy or drama. As long as the movie contains comedy, I'm going to consider it comedy. As long as it's considered a drama, I'm going to consider it a drama. Okay, because it's listed in there. Okay, probably a naive assumption, but again, just going to look at that for now. All right. So again, this is going to be our one-hot encoding portion that we're doing. And if there's any questions, guys, again, feel free to put this in the Q&A. More than always happy to answer them for you. Okay. And now what we can do is I can actually count the number of genres that occur across the TV show. And I can also do a similar thing for the movies. So when we do that, let's see if there's anything that kind of stands out to us, okay? So for example, across all TV shows, right, that we have, 481 of those TV shows were listed, had drama listed in them, okay? On the TV shows in Amazon, up to 2021, that's when this data set was created, 406 of those TV shows that were there on Amazon, right, had a kids-related genre on them. Okay, so which maybe means like if you have small children, might be a good platform for you to use if you care about showing kids shows, right? 314 of the TV shows had documentaries, 270 had comedies, you know, and so on and so forth until we go down the line. Okay, but hopefully you are seeing this now, right? How we're able to actually go ahead and just count, right, how many times drama occurs inside the TV shows, and we're able to do this across all the movies now. So as long as we have dramas, we're counting it, right? We don't have drama being separate from drama comedy. So the signal from this, if you want to do that, would be separate, right? We don't necessarily want that. Okay, but we can also do the similar thing for movies. Okay, so for example, out of all the movies that were inside the data set, right? 3,000 of them had drama in them, or had drama as part of their genre. 1,800 of them had comedy. So there's a big gap between the first one, drama, and comedy, right? So that probably means that the majority of them are going to be drama. So it might mean in this case that maybe drama is a generic kind of identifier for genre. You know, I don't know, right? That might be something to consider if it's occurring that much. Or maybe every single movie has drama in there, or maybe we just care about drama movies. Maybe that's just a thing that movie studios realize, like, hey, people love drama, so let's put it in there. Let's make it some type of drama so people will watch it. I don't know, right? But again, it's occurring a lot. So it's occurring across a bunch of movies that we have inside our Amazon data set. A lot of action, some horror, kids, things like that. Okay, and you can see Western is down here at the bottom, which I love Western, so that's kind of that's cool. It's cool that Amazon has some for me to watch. Okay, so we're gonna kind of put a pause on this. We're gonna come back to this genres data set, or this kind of one-hot coded data set later on. But I want to do some duration exploration before we take this and we do some more exploring with it. I'm gonna show you some pretty cool stuff. Okay. But before we do that, are there any questions, y'all? Questions, comments on kind of what we've done so far? On the kind of the one-hot encoding, the Python code, anybody want me to reiterate the code that we've done? Any questions whatsoever? Again, this isn't the only way to do it. It's just kind of the quick and easy way that I found to do it. Oh yeah, but again, quick and dirty. All I wanted to do is go ahead and get everything that's past these 4 columns right here. Yeah, exactly. So if we kind of just do a value count without that, we're going to kind of get the title, type, and listed in, and genres counts as well inside of these columns, which I don't want. Actually, you'll get an error if you can't sum down them. So I only want everything past the 4th column that's inside here. That's why we did that. And everything past the 4th column is going to be exactly the genres. So that's why. Yeah, just some quick and dirty again. Yeah, for sure, but definitely. So the model being the most label binarizer. Yeah. So for this guy, what this is doing, right, is it's pretty much going into this genres column right here. This is actually a really cool thing to do, because I've actually found this kind of tool being really useful in like NLP stuff. So for example, when we're looking at this genre, all of these lists that are occurring inside the genres column, right? What the most label binarizer is going to do, it's going to go into all of those different lists, right? And think about it as pretty much concatenating all of them. And it's going to start seeing, okay, which unique values inside all of these lists are occurring, right? So for example, is comedy unique? Is drama unique? Is action unique? Documentary unique, right? All these different things. And what the most label binarizer is going to first realize is it's going to say, okay, I know which one of these entries inside all of these lists are unique, okay? So now what I want to do is pretty much say, okay, I'm going to identify for this list, when does comedy occur? When does drama occur? When does action occur? Okay. And I'm going to identify, right, if action, comedy, drama, horror, suspense occur by essentially identifying what occurred inside this list. And I'm going to do that via ones and zeros. Okay. And that's what we're seeing here. So the most label binarizer is going in there and it's saying, okay, I understand what this list looks like. I understand all the unique entries that are occurring inside of across all the lists in our data set. And what I want to realize, okay, is if I look at this particular list, out of all the unique entries that I've seen, right? Which entries that I've seen occur inside this list. So it's going to look at this list and it's going to say, oh, I've seen comedy before. I've seen drama before. So I'm going to make those columns that I've seen, those classes that I've seen, and I'm going to flag them because they've occurred there. If they have not occurred there, I'm going to make the rest of them 0. And it's going to do that for every single list that I pass it. So for example, action, drama, suspense, the most label binarizer has seen action, drama, and suspense. So what it's going to do, because action has occurred, it's going to flag it under action. Because drama has occurred, it's going to flag it under drama. Because suspense has occurred, it's going to flag it under suspense. And then nowhere else is it going to be flagged. So that's what we're doing there. It's just a way for us to kind of one-hot encode these different list features that occur. So if ever you want to go from text to features, like in this way, So for example, let's say you're doing some natural language processing and you want to understand, okay, I just care if this particular word occurred inside of this, this note or this healthcare response. I don't care how many times it occurred. I just want to understand if it did occur, right? This multi-label binarizer is one way to do that. So definitely have used this before for various NLP tasks in the past. And if you want some more information on this in the notebook, I actually provide a link for you if you want to see it. So yes, I want to leave Google Colab. You can see the scikit-learn documentation if you're curious. But that's pretty much what we're doing there. Any other? Nope, you're very welcome, man. Very good. Yeah. Any other questions, y'all, on what we're doing there before we kind of take a little bit of a detour, and then we're going to come back to this. Like you're literally seeing my thoughts as I was looking through this data, which I'm not sure if it's good or bad. Any other questions? Cool. Okay, so now another interesting thing that I found here was the duration column. Okay, so the duration column that we have inside of our data set, if you look at it above at the very beginning, right? You see here how it has like 83 minutes, 51 minutes, 77 minutes, you know, all these different type of minutes. They have seasons, right? Like, what does that actually mean? That's interesting, right? So what I wanted to do is actually kind of do a deep dive into that and then maybe come back to the genres to kind of understand how those two, like for example, how long on average are horror movies or how long on average are comedy movies, you know, things like that, okay? So if you want to answer that question, what we got to first understand is what in the world is this duration column doing, okay? So the first thing I want to understand is if I look at this, right, what are the unique entries that occur inside of this duration column? So how you can do that is just do it by doing df.duration.unique, okay? So you can see all the unique entries that are occurring inside of this data set, all right? So we can see seeing minutes, we're seeing seasons, minutes, seasons, different durations of minutes. That's kind of interesting, okay? Seasons, things like that. So when I'm looking at this, I'm thinking, okay, well, what would have minutes and what would have TV shows? Oh, excuse me, what would have seasons, right? Like, what does that actually mean? You know, could we have, you know, some things being intermixed? So I'm not too sure, right? It's very interesting. So, I mean, I'm curious, right? Let me ask y'all, right? When you see the minutes and you see the seasons, right? Like, what kind of correlations are you thinking about in terms of the type that we have in the data set? Any ideas? Like, we see minutes, we see seasons. Any correlations that maybe we would think of to see between the types that appear in the data set? Any ideas? Very good, Lisa. Very good. Yeah, exactly. We can look at, so Lisa had a very good point, right? So I see seasons as TV. That was my thought too. That was my thought too. I'm thinking seasons. I'm thinking, well, I don't think of movies as seasons, right? So exactly, we can look at TV series versus movies, right? We can look at TV series versus movies. So what we have to do first, we kind of have to validate that, right? Like in the data, are movies only going to be mapped out as minutes and are TV shows only going to be mapped out as seasons, right? Because if that doesn't work, our assumption or our hypothesis is already failed, okay? So the way you can do this, again, quick and dirty way of doing it, not the only way of doing it, but what I'm going to do is I'm going to make a new column, which I call very uncreatively duration season. I'm going to look at the column. I'm going to look at duration, the duration column. I'm going to apply a lambda function again. So let's go to lambda functions. And what I'm going to do is I'm going to say, I'm going to put true in that column if season occurs inside of the duration column. And if it doesn't, I'm going to put false. Okay. So in theory, if I did this correctly, right, every TV show, right, the duration is going to have season, right? So if wherever it's true, it's going to be a TV show. Wherever it's false, it's going to be a movie. Okay. So let's see if that hypothesis is correct. So what I'm going to do is I have this duration season column now. I'm going to pretty much count the number of times that the types occur. and I'm going to separate them by that duration season feature that I just generated. So when I do that, look what happens. Interesting. So all the movies have a false in this duration season column that I just made. All of the TV shows have true inside of this duration season feature that I just made, right? So what does that mean? That means that all the TV shows our hypothesis is right. They're going to be measured in seasons rather than minutes. Okay, which again, it makes sense, right? It kind of makes sense. So what we want to try and do now, so we kind of validated that hypothesis, right? That all of the movies are going to be valid, are going to be in minutes. All the TV shows are going to be in seasons. Okay. So let's go ahead and let's do some exploration for the movies first. Okay. So what I'm going to do is I'm first going to go ahead and peel down to all of the movies. So I'm going to do this via the duration season feature that we just generated. If you want to do that versus the type, that's also okay. However you want to do it, it's up to you. And inside of this movies column, I am going to make a new feature called duration time. Okay, again, very uncreative. But I'm pretty much going to look inside of that feature. I am going to apply another Lambda function. I am going to apply that awesome method called split. Okay, I'm going to take the 0th entry inside of that split method, and then I'm going to cast it as an int. Okay, so there's a lot going on here. Let me kind of walk it through you step by step. Okay, so for example, I have 10 min, right, as a potential entry inside of a movie duration. Okay, when I call dot split, look what happens. So when I split it on a minute, right, look what happens. I have a 10, right, and I have a space, right? So what I want though is I want this 10, right? I don't care about the space because I know that all of those entries inside the duration have min. So I'm gonna go ahead and split it on min. I'm going to take that 0th entry here, which is gonna be 10, and then I'm gonna cast that as an int. So it's gonna be 10, the actual numerical value 10, not the string 10, okay? So we're gonna go ahead and cast that as an int to make sure that we have numerical entries inside of these values. Okay. Now, again, if all of those guys were not ints, you might have to make it like a float type or something like that. But for now, ints are going to work just fine. And you see here how we're going to have our new duration time column being 115, 48, 78. These are all going to be minutes that we're going to be looking at. Okay, inside of the movies. Now, look, check this out too, which is actually pretty interesting. If I draw a distribution of all of the duration time of our movies, right? So this is going to be essentially a curve or a distribution of the amount of time that we have inside of our movie, right? So for example, we're seeing a bunch of movies are occurring around that like 95 to 100 minute mark, right? But here's something that, again, first off, which makes sense, right? Like a lot of movies on average are like 90 minutes, like an hour and a half. Like you normally don't see many movies that are way past 2 hours or 3 hours, right? So, you know, definitely something to think about, right? But when I was looking at this, right, I was noticing, look at this. We have some movie times that are like well past 400. Like, why? Like, why is that the case, right? That's kind of interesting when you think about that, right? So let's go ahead. Let's describe the statistics. We see here how the maximum value, the maximum movie length that we have in our data set is 601 minutes. The 75th percentile is about 106. So the majority of our movies, right, are about an hour and a half long, right? Actually, in fact, the median of them is near that, right? But again, we have these movies which are really long. Like, let's understand why. So if I do this, what do we notice? So I'm going to look at all the movies which have that duration time greater than 400. I'm going to sample them and look at what we get. All of these movies, what are we looking at here? Black screen, ocean waves, sleep for 9 hours. Ceiling fan, sleep for 9 hours. 9-hour rainstorm, right? We have a bunch of movies, right? Which Amazon has on their platform, which are really kind of ambient noise movies. So I thought that was pretty interesting, right? I didn't realize Amazon even had that. And fun fact, you look it up on Prime, they do have it, right? That's pretty cool, right? So we have a bunch of movies with really long movie time. And this is the reason why. So that's interesting. So what if we go ahead and take out that long tail? I'm going to take out that long tail of distribution times, and you'll notice, okay, this looks a little bit better at least, right? It looks a little bit more normal, which kind of makes sense. But when I'm looking at this, right, like there's still some movies that have like 0 length, right? Like, again, why? Or less than 10 minutes. Like, why, right? So if I look at this, it looks like the majority of them are like comedies, maybe comedy skits, they're kids shows, dramas, so very interesting. If I kind of plot or look at some of these movies with less than 10 minutes, you see here how, title before I see onboarding. I'm not sure what that is. Cast 1, 2, 3. Maybe it's like a test, kind of like dummy record that they have. We bought a zoo. Okay. Monster truck counting for kids. Interesting. What if we want to look at just the movies with 0 length, for example? Molly and Me is a movie with 0 length. That's there. That's interesting. Like, why is that the case? Paradise Canyon digitally remastered, again, movie with 0 length, things like that, right? So we kind of see maybe some test data that Amazon has inside there. Maybe we might need to remove that. Things like that, right? So if you go ahead and just take out both of those like weird tails, your data should look approximately what you would think it would look like, but it looks almost normal. It is a little bit skewed, but it kind of makes sense that a lot of the movies are going to be approximately around that 90-minute length, right? And if you want to, you can describe it. All right. Now, I know I kind of cleared up on time here. So let me go ahead and kind of walk through this next movie duration exploration, and then maybe we can go towards the end and kind of show y'all. I kind of show what this looks like for the movie duration. It's pretty much the exact same thing for the TV duration. Then we kind of jump over to the topic modeling and recommendation stuff after this one. Okay. So before we do that, I want to kind of show y'all, like, this is actually pretty interesting, right? So what I wanted to first look at was, are there any interesting insights between movies as well as, or movies and genres and their duration, right? So for example, how long are horror movies, right? How long are TV shows? Excuse me, how long are like comedy movies? How long are historical movies? Things like that. So if we do this, again, you notice here, right? So we do a simple group by. A lot of these that we're seeing here, right? Again, we have to, without the previous genres data frame that we just had, we have to have these kind of concatenated strings, which are kind of annoying to consider, right? So I don't want that. Instead, what I want to do is I want to use that genre data frame that I just generated to concatenate or combine the movie column from the genre column, right? So when I do this, look what happens. So I'm gonna go ahead and merge these in pandas. So I'm gonna do a df.merge. Think about this like as like a join, pretty much. I'm gonna take the movies data frame that I just made and the genre data frame that I had above, remember with all the one-hot encoded columns? I'm going to join them on the title, so the movie title, as well as the genre that's there. So these genres right here. And then I am going to get I'm gonna make it a left join, okay? So when we do this, look what happens. Now I have my movies columns that I have right here, but I also have them with all of my different genres that I cared about. So now that I have this linking between, right, the movies, the duration in minutes, as well as all of the genres, I can start doing some calculations to understand, okay, well, how long on average are the movies that I care about, the genres of movies that I care about, okay? So the way I'm going to do that as follows. So first off, I'm going to do the genres that I care about. And I'm going to take out the genre of TV shows because in theory, there shouldn't be any movies with a genre of TV show, right? And the way I'm going to do this calculation of the statistics of understanding how often certain genres occur for a particular movie, as well as how long they are, I'm going to do it via a basic group by, okay? So I'm going to take this data frame that I just found, this guy up here. I am going to group by action. I'm going to look at the duration time column, and then I'm going to group by. So again, this is for the action column, but I'm gonna do it for every single column, for every single genre. And then I'm going to calculate how often it occurs versus how long on average duration time is, and then I'm gonna reset that index. So you see here, so in this data frame, right? Action occurs inside of the movie data frame 1,500 times. And also the average movie length across all the movies that contain action is going to be about 101 minutes. Okay. So what I'm going to do is pretty much do this exact same calculation. And I'm going to do this for every single genre that occurs inside of the data set. Okay. So I'm going to do this for action. I'm going to do it for comedy, for drama, for historical, all the different genres that occur. So how am I going to do that? I'm going to keep track of this inside of a dictionary that I have here. And then I am going to go ahead and loop through all of the different genres that I have inside of my data set. And when I have all of these genres, I am going to do the exact same calculation that I just did here. So I am going to group by the genre. I'm going to look at duration time. I'm going to see how often that genre occurs, as well as how long on average those movies are. I'm going to reset the index. Then after I do that, I'm going to go ahead and get the size value, get the average value, and then I'm going to put it inside of this dictionary. Okay. And when I do that, I'm going to have this nice dictionary that's cleanly organized for me. That kind of tells me, okay, for the action movies, I have 1,500 of them, and they're going to be on average about 101 minutes. Adventure movies, there's 230 of them, on average about 101 minutes. Animation, 279, 53 minutes, so on and so forth. So I can do this for a bunch of different movies that I have here. Okay. And then what I can do is I can go ahead and start looking at them from I can order them by essentially the average duration time. Okay. And I can start seeing, right, international movies are going to occur about 284 times inside the data set. And they're going to be on average about 130 minutes long. So well over, 2 hours. Okay. But again, this is kind of hard to look at, right? So what I want to do instead is I'm going to go ahead and plot this as a data set, or excuse me, as a bar chart that looks like this. Okay. Or a bar plot. And this is exactly the data frame that I showed y'all before, right? How, or in the slides, right? How we can see now, again, we're not having any noise between international and like international drama being misconstrued, right? International is going to be its own little thing. And we can see that across all the movies that contain international, it's going to be about over 120 minutes. Some things that I find interesting, so I love horror movies, and I kind of know from watching enough horror movies that they are going to be about an hour and a half long. I kind of knew that before I did this, right? Kind of a gut feel. At least for Amazon's data set, it looks like they're on average about 90 minutes long, which was pretty cool to kind of see. Let's see, what else can we kind of see from here? Maybe some fitness movies, right? Which makes sense. Fitness movies are not necessarily going to be the longest thing. They're probably going to be quick workouts. I don't think you want like a 2-hour fitness movie to watch and do. That might be a little bit much, right? So fitness movies are kind of the shortest. Kids movies are about an hour long. It kind of makes sense from kind of what I know about those kids movies. What else do we maybe see here that's interesting? Again, science fiction movies are about the same thing as horror. So just various things like that, right? We can kind of start seeing this, but again, we couldn't see this signal without taking the features and first splitting everything together. Okay. So it is something to keep in mind going forward, right? This is kind of why we want to definitely do the cleanings of this for sure. Oh, let's see. So can ChatGPT or other OpenAI tools find all possible correlations in a given data set? That's a good question. I don't think ChatGPT can do that out of the box right now. I know there are some type of LLMs that are trying to do that. And I know that there's been some moderate success, but I don't think ChatGPT can do that, at least immediately. Maybe the GPT-4, I know Gemini can do some pretty cool stuff with data now that Google has. Yeah, I'm not sure if they can do that at least immediately right now, definitely. And if it can, it's pretty elementary from what I recollect. That's a great question. Alrighty, so how about this? I know we spent a lot of time exploring the data. I do want to make sure we kind of show you all the recommendation stuff. So I pretty much do in this next few cells here, I will run them for you. And I'm actually gonna put this completed notebook onto the GitHub if you want to see it. But it's pretty much the exact same thing we just did, but just with TV shows. Okay, so I figured for now, let's go ahead and kind of skip over this if you don't mind. I do kind of want to show you all the topic modeling and kind of how we can do a user-based query recommendation. Okay, at least with the very basic kind of input. As well as we're going to skip the country breakdown just for now, just for timing's sake, okay? But again, I will run all of this for you. That way you have it available to you, and you can actually look at it if you want to look at it, okay? But for now, what I want to do is I actually want to understand descriptions and do their recommendations and understand what those look like, okay? So the first thing we want to do with these descriptions, right, is I first want to be able to understand what they're actually saying, right? So these movies, we can kind of look at them. We see this like a small fishing village, a metro family decides to fight cyber criminal threatening their stability and pride, right? A bunch of different movies, kind of descriptions that we see here, right? And whenever I look at some type of text like this, y'all, what I always want to do first, understand, can I get a feeling for how long these descriptions are, right? That's really going to be the big thing, okay? So what I want to do is go ahead and I'm going to look at those descriptions. I'm going to apply another Lambda function, and I'm pretty much just going to do a very basic splitting along the spaces just to count the number of tokens that I have inside of my data set. Okay. Now, again, there's different tokenizers that you can use. I'm just doing this quick and dirty. I just want a feel for what we're doing there. Okay. So we can see for these movies, we're seeing that the description is about 42, 64, 35. Okay. So again, interesting. The way I like to do this, at least in practice, is I like to plot violin plots to pretty much understand, okay, for movies and TV shows, right? How often do these description links occur? Okay. And where are they mostly occurring around? This is kind of why I really like violin plots. So we can see here that for movies, right, the bulk of the movie descriptions that we're seeing here are going to be around, I don't know, what do y'all think? Like 30-ish characters, 30-ish tokens, right? There is a couple of them that are going to be up here, like in the 65-ish range, 70 range, right? But we can also still see the percentiles, the 25th median and 75th percentile in the violin plots, which is nice. And we can also see that in the movies, there are a lot of big outliers that are occurring. So again, I don't really worry about that too much because what we're going to do is we're going to take these descriptions and we're going to embed them via these large language models. What I want to make sure is that these links do not pass the context link inside of our large language models, right? Because large language models can only have like maybe a few hundred tokens in its context link, right? So if you go past that context link, what happens is the language model has to truncate it, and you do eventually, unfortunately, lose some information, okay? So pretty much looking at this, I can see, for any language model that we're going to be looking at today, we're well below the context link limit, so I think we're going to be fine, okay? So I think we're okay here with the description links. We're not gonna have to worry about any truncation. So what I'm gonna do now is, in order to find some like general recommendations, right? Because when you think about recommendations, y'all, it's really hard to do this with the data that we have here because there's not user-based data, right? Like I have just general movie-based data, right? But if you want to generate a general recommendation algorithm, what you really need is you need user characteristics. So for example, I need the number of times that a certain person liked this genre of movie, or I need the movies or shows that they've watched recently. I need, how often have they watched this particular, movie of this particular type, right? So like The Office, or I don't know, Dexter, or whatever TV show we're looking at, right? So I can recommend similar genres of those particular TV shows, like comedies or suspense, thrillers, things like that. For this data set, we don't necessarily have user-based characteristics like that. But what we do have is we do have descriptions, which is what I'm looking at here, right? So what we can do, for example, imagine you go on to Netflix and you type in, sorry, my computer went dark mode. If this follows anybody, let me know. I can switch it back. But for example, if you go to Netflix or any kind of system, let's say I want to watch a movie about sports, or I want to watch a movie about zombies. I want to watch a movie about World War II, right? Whatever it might be. In theory, these platforms can hopefully recommend to you those kinds of movies, okay? Or you can actually type in the exact movie title, and this should return movies back out to you that are going to be there, okay? So what I'm going to do is the former. I'm going to type in some general description of what I'm looking for, because imagine it's Friday night. I never know what I want to watch. I just want to watch a romantic comedy. So I'm going to have my little quick and easy recommendation algorithm just generate some movies inside of this data set that give me romantic comedies, okay? Based off of the descriptions, okay? But if you want to generate a full recommendation algorithm, you need that user characteristics. And that's a little bit outside the scope of what we have, at least in this data set. So just something to keep in mind there, okay? But how are we going to do this regardless? Based off of the movie descriptions, I'm going to go ahead and I'm going to import what's called a sentence transformer, okay? So a sentence transformer is going to be a type of LLM. And what's really nice and powerful about it, and again, you will need a GPU for this, y'all, to make it efficient. So if you do have a GPU available, that's awesome. But if not, just follow along with me. All of this will be available to you in the GitHub. Okay. So a sentence transformer is a type of LLM that what it essentially does is it allows us to get the best, it's trained essentially to get the best contextual relationship that occurs not just in a word, right? But in a sentence or a paragraph, right? Of text. Okay, so for example, these sentence transformers, what they do really well is being able to understand from a contextual standpoint what this description is saying. Okay, not just what the individual words are saying, but what the description is saying. Okay, what we're going to do is we're going to leverage that contextual understanding that these sentence transformers can do. Okay, the sentence transformer that we're going to use, it's going to be this all MPNet based V2. This is just a basic sentence transformer that's available. If you want to find out more about this, you can actually go into, I give you a link here for you to look at it, just a documentation. This sentence transformer is kind of like, it's a basic one, but you have a really nice big context link, and it's more for general purpose. So that's kind of why I used it. All right. So what I'm going to do first is I'm going to take the movies that I care about, right? Let's see. So it kind of sentence transformer tells if there's a social security number in a given text. Ooh, I don't think so, bud. Yeah, I don't think so. Because it's only really going to give us contextual information. Ooh, that's kind of a tricky problem. That might be more like an NER kind of problem. It's like a name entity recognition problem. It's a little bit outside the scope of what the contextual stuff is going to give us, unfortunately. Yeah. So I don't think we can do that at least immediately. Okay, so what we're going to do is we're going to get, I'm going to make a movie dictionary where I'm pretty much just going to get the movies that I care about. So the titles pretty much. I'm going to get their descriptions. I'm going to go ahead and get the movie descriptions out. And then what I'm going to do is I'm going to take all of those movie descriptions and I'm going to embed them or encode them with the sentence transformer that I just pulled in. Okay. Now, again, this will take some time. So if you do this on a CPU, unfortunately, it might take the remainder of the time that we have together. Okay, so definitely do this on a GPU. It's going to make the calculation much easier. Okay, because we do have to encode all of these different things together. But in theory, once we have all of the different descriptions instead of our data set embedded, we should be able to provide a user query and be able to find the most similar movies to the user query. So we can recommend movies based off of what you want to watch. Okay. So if I do this, the embeddings.shape, we can see that each embedding or each description is going to be embedded in a vector 768 dimensions long. Again, this is the context length of the sentence transformer. This is why I wanted to make sure, right, that the descriptions did not pass that, right? If they pass that, you gotta be a little bit worried. Okay. So now we're pretty much ready to generate some recommendations. Okay, so I have a couple of examples here. So for example, let's say I want to watch a movie about sports. Okay. Let's see. Yeah, but that's a good question, Pedro. So I'm pretty much just using the one that comes with the Google Colab Pro. It's going to be the T4 that's available. Yeah, that's what I'm doing here. It's going to be a high RAM guy as well. So it's a pretty beefed up one that I have to use for this. But it's going to be just a T4 from Google, I believe. Yeah. Okay, so let's say I want to watch a movie about sports. Okay, and I want to watch a drama about sports. Okay, so what I'm first going to do is, and this is kind of how it works on the back end, I'm going to take that user query. I am going to embed or encode that user query. So now when I do that, look what happens. I'm going to have a vector that's going to represent my desired, if I can type, embedding. There you go. I'm going to have a vector that's going to represent my query. So this vector is kind of the numerical equivalent to this user query. Okay. So now what I'm going to do and what I'm going to say is I'm going to say, okay, I know how this user query, this drama about sports can be encoded numerically. So I'm going to take it and I'm going to compare it against all the other movies that I have inside my data set. And I'm going to peel out the ones that are most similar to my query. So in theory, I'm going to go ahead and get only the most similar movies that are going to be about drama and sports. So how you can do this is going to be via a cosine similarity. That's why I pulled it at the beginning. I'm going to go ahead and reshape my embedding. I'm going to compare it against all of the embeddings that I have in my movies. That's what took a little while to just do. I can get those top 5 indices, and then in theory, I can go ahead and go to the movie dictionary. I can peel out the movie that's most similar via to less similar, and I'm going to do the top 5. Okay, look what happens. So this right here, Underdogs, this is going to be the top movie that I could recommend to the viewer that put it in. I can recommend Underdogs. It's going to be a story of a small town high school football team destined to play their crosstown rival. Okay, or Fever Pitch. It's actually a really good movie. I like this movie. This is going to be another movie that I can recommend to the user who inputted this desired, entry. They want to watch a movie about sports. New Providence, Score, Crooked Arrows, right? Again, what we're doing is we're basing this off of the descriptions, okay? But again, this is a movie about sports. What if you wanted to watch a movie about World War II, okay? So my movie query, or user query is going to be movies about World War II. I am going to get the similarity array, get those top 5 indices. And then in here, let's see what movies I can recommend to myself. I have the title chosen. Harvey Keitel stars a Hungarian citizen during World War II. He becomes a leader in Israel. Yeah, so it looks to me like there are some movies about World War II, right? So we're kind of seeing this is like a documentary about World War II, right? And look at this too, y'all. Look what happened. You see how World War II is kind of being conjoined with II here. This is why sentence transformers are so good. They can pick up on that context. Okay. So this is kind of like an idea of what you can do. Okay, so we need real-time recommendations as users is typing something. So the GPU stuff runs only once, and we can reuse the transformers. Oh yeah, dude, for sure, definitely, yeah. So as long as you have the embeddings, you can pretty much do the inference as many times as you desire. Exactly, for sure. That's definitely an option. And then you have to set up your kind of inference pipeline to do that correctly on those GPUs, but you can definitely reuse the transformers, for sure. Because in theory, you would have these embeddings kind of stored away, and you would kind of peel them out whenever you needed them. Okay, yeah. And this is, again, something I recommend you play around with, right? Type in your own query here and see what movies in the data set are most similar to it. That's a fun little exercise I found. I did like movies on zombies, suspense movies about books. It's really cool. The sentence transformer is really able to kind of return things that are really similar to you. Okay. So that's kind of the recommendation system that we're kind of talking about, y'all, again, based off of the user queries. So this is one type of user recommendation algorithm. And in the last 2 minutes, I can actually show y'all how we can topic model these movies as well. So a bunch of different things that we're doing here. This is what's called BERT topic. It's also using the sentence transformer as well. And to give you a little bit of a quick TLDR on this and how it's doing this, I know we're running on time here. This cell right here is going to take some time now. So please, if you are running along with me, make sure you start running it now because it will take about a minute. But what we're going to do here with topic modeling, this is what's called BERT topic. It's a very, very awesome way of topic modeling your descriptions. Because remember, imagine you have a bunch of movies here. And these movies, I can have 10,000 of them. I can have 1 million of them. I don't want to have to look through all the movies to understand, okay, well, do we have a bunch of horror movies here? Do we have suspense movies, comedy movies, whatever it might be, right? So what we can do is we can take all of the descriptions, right? We can embed them via the sentence transformer. After you embed them in the exact same way we just did, right? So you're going to get a kind of contextual representation of what the description is. You can then reduce it down via any dimensionality reduction technique that you like. So in this case, I'm using UMAP, right? But you can use HDB scan if you want. You can use UMAP, you can use PCA, you can use TSNE, whatever you would like to reduce down. Then after you reduce down, you're going to cluster them together, right? Via this HDB scan, you're going to go ahead and tokenize these topics, and you're going to make this kind of clustered TF-IDF matrix, which just for timing's sake, I won't go into, but you can start feeling out the topics that can occur, okay? Oh, Nepal. Yeah, so you can use these sentence transformers for classification. But the way you do that, you got to rig it up a little bit different. And if you're interested, we can talk about it more. But it's definitely possible, 100%, definitely. You can do things like text classification, multi-level classification, things like that, for sure. And topic modeling is a type of text classification. So that is pretty neat. All right. So again, we're going to take all these descriptions and start clustering them together. And let's see if we can find some interesting topics. And I know I got to finish here in 2 minutes. I'll go ahead and run these next few cells for us. But we can see, for example, there's a ton of different topics here. We see here, like one topic is going to be about kids, nursery, song titles, little rhymes, things like that. We have life, young world, family, movie, interesting. What are some other topics? Video, natural beast, postcard, whatever it might be. And if we do this, we can go ahead. I kind of just run this through y'all for y'all real quick. Because I know we're out of time here. Again, I will post this for us. That way, if y'all want to see it, you can start seeing all the different kinds of topics that are maybe going to start appearing inside of the data set. And this is, again, the similar thing that we showed y'all at the very beginning inside of this slide right here. So you can start seeing how the haunted ghost or how the suspense movies or horror movies are occurring. You can see it in the movies. We have comedies, we have rock bands, we have different things like that occurring. So just something to keep in mind there if you're curious going forward. Okay. But I know we're out of time here, so operations, I'm not sure if y'all wanted to go ahead and close this out. But that's all I have for y'all today. Again, I will post the completed notebook. I will make sure to go ahead and put this up on the GitHub so you can have it. You can go ahead and peel it out. You can go ahead and pull it down. Again, we're here to help. If you have any questions on IK, operations is here to help you. IK is here to help you, and we're here to chat with you more about it, okay? But thank you all so much for your time, guys. I really do appreciate it. And IK, in the last 2 minutes, I will go ahead and turn it over to y'all so I close this out. Thank y'all so much.
Thanks, Andrew. Thank you everyone for going with the session. If you have any questions, feel free to put it in the Q&A box, or you can raise your hands. We can unmute you. If you have any questions with respect to the curriculum or how our data science course is, and whether you are the right fit for the course, you can ask it here, or you can reach out to our program advisor. You will be getting a mail from our end, and you can book a one-on-one session with them. And that will help you to get started and understand more about our courses. Okay, looks like there are no more questions. So thank you, everyone. Thanks for your time. Thanks, Andrew. Thanks, Sachin, for taking out time to do this session. We really appreciate your effort and looking forward to more such sessions in the future. Thank you.